In section 6.3, we're going to look at another application of integrals, and that's finding the area between two curves. In chapter 5, if you recall, we learned that if we had a function that looked something like this, and it was f of x, and we had some x value of a to b, and we wanted to find the area between the graph and the x-axis. To do that, we calculate the integral from a to b of my function, and that would give me my area. Even if the area dipped below the x-axis, remember the area below the x-axis was negative, the area above was positive, but the integral would take the positive area, subtract away the negative area, and give you your net area. We can also find the area between two curves using integration. So we have the function y equals x and y equals x squared minus 2, and I want to find the area between these 2 points, which is this shaded region right here. Well, the first thing I need to do is I need to find my intersection points. And in this example, we'll do those algebraically. So to do that, I'm going to set these two functions equal to each other because I have y equals x and y equals x squared minus 2. Therefore, x must equal x squared minus 2. I set this equal to 0. Get that. And solving each of these, either x minus 2 equals 0, so x is 2, or x plus 1 equals 0, so x is negative 1. So this guy is at negative 1, this guy is at 2. Now, to find this area trapped between these two curves, it's very simple. We do the integral from my intersection points, negative 1 to 2, and we look at this region, and which curve is on the top of that region? Well, it's the function y equals x, so it's top curve minus the bottom curve, which is the parabola, with respect to x. So if we were to simplify this by distributing the negative sign, I would get that. And yes, we could integrate this manually using our techniques in chapter 5 to evaluate. But now we're going to learn how to do this on a calculator. So to do that, we're going to get out the TI Nspire, and we are going to do a calculation. And right beside number 9, I'm going to hit that button. That'll brings in a bunch of features, and I'm going to get or click on the definite integral. And my definite integral is going from negative 1 to 2. So again, make sure you use the negative key for the 1, which is right down there in red. So negative 1 to 2 are my limits. And my integrand was x minus x squared plus 2. So x, I'll get this out of the way, x minus x squared plus 2. And I must tell the calculator I'm integrating it with respect to variable x. And then I just hit enter, and it is 9 over 2. So my area trapped between these two curves is going to equal 9 over 2. So again, find the intersection points. Those become the limits on the integrand. And then it's the top curve minus the bottom curve over the area of the region we're looking for. So in general, we have this. It says if f and g are continuous functions, and function f is bigger than function g, so on the graph, function f is the top function, g is the bottom function throughout the interval a to b. The area between those two curves is going to be the integral from a to b of f of x minus g of x. Now, sometimes our curves might not intersect, like in this example, but they want us to find the area of the region bounded by the parabola x squared minus 2x plus 3, which is the top parabola, and negative 1 minus x squared, which is the bottom parabola, going from x being negative 1 to x being positive 2. So those become my limits in this particular case. So negative 1 and positive 2 are going to become my limits. So to figure out this area, it's going to equal the integral from, again, I'm going from negative 1 to 2 of the top function, which is my parabola x squared minus 2x plus 3, minus the bottom parabola, which is negative 1 minus x squared, and I'm integrating this whole thing with respect to x. So we can clean this up a little bit. This would be x squared minus 2x plus 3 plus 1 plus x squared dx. And I would have 2x squared, if I collected like terms, minus 2x plus 4 dx. And now we'll go to technology. So again, I want the definite integral from negative 1 to 2. And my function was 2x squared minus 2x plus 4. So 2x squared minus 2x plus 4. And I'm integrating with respect to x. Hit enter, and that area is going to be 15. So sometimes, if the curves don't intersect, they're going to give you some vertical lines where they want you to find the area between, so those vertical lines will become your limits. Okay, if we're asked to find the total area of this shaded region, again, we need to find the intersection points. So to find the intersection points, again, we can do this algebraically. I'm going to equate x cubed to x, because they both equal y. Now, one of the things students like to do at this point is they like to divide both sides by x, but you can never divide by a variable because you're going to lose one of your solutions. So what you're going to do is you're going to subtract the x over to make it equal 0, factor out an x, and then factor as a difference of squares. So therefore, you get x equaling 0, x equaling 1, and x equaling negative 1 as your intersection points. So this intersection point is negative 1, this one is at 0, this is at positive 1. Now, the other thing you have to be careful of in this question is from negative 1 to 0, the top curve is the cubic function, the bottom curve is the line, and then from 0 to 1, the top curve is the line, the bottom curve is the cubic. So to find the area, I'm going to set this up as two integrals. Negative 1 to 0, the top curve is x cubed minus x dx, and that's going to give me my first area. Then I'm doing the area from 0 to 1 of x minus x cubed dx. And now we're going to go to technology again, and to clear this screen, I'm just going to go menu, actions, clear history, and we're doing the definite integral. And the first one is going from negative 1, whoops, not negative 0. Get this out of the way. Negative 1 to 0. And it was the cubic, so it would be x. Remember, to get a cubic, we use our little hat key here. X cubed minus the linear function, which was x dx. And then I'm adding to that, whoops, I don't want to do it like that. And then, is there a space? Plus the integral again, so math, not math, hit the button beside number 9. That's the old TI-83. I used to always have to hit the math key, but this is the TI Nspire, so it's just the button beside number 9 to get the definite integral again. This time we're going from 0 to 1, and now the top function is x minus x to the power of 3 dx, and then if I hit enter, my answer works out to be 1/2. So the area trapped between those two curves is going to equal 1/2. Okay, I encourage you to pause the video and give this one a try. Okay, I'm hoping you had a chance to try this one. Again, we have the functions y equals 2 minus x squared, which is a parabola that is shifted 2 units up, and it's opening down. Again, this is not drawing scale. I'm just drawing a simple sketch. And y equals negative x is going to be a line coming through something like that. And I'm looking for this region here. Again, to find the intersection points, I'm going to equate two functions. So I'm going to have 2 minus x squared equals negative x. Set this function equal to 0. And I'm going to get the x minus 2, x plus 1. So again, x is 2 or x is negative 1. So my area is going to be the integral from negative 1 to 2 of my top function, which in this particular case is the parabola, which is 2 minus x squared, minus the bottom function, which is the linear. And now I just get out my calculator and we'll calculate this again. So, see if I can make this a little bigger so you can see. Or I can just move it over a bit here. Well, you're not going to be able to see the answer, but anyways, this is going to be the definite integral from negative 1 to 2 of my top curve, or for curve 2 minus x squared plus x. So it's going to be 2 minus x squared plus x with respect to x. And that answer again is 9 over 2. So the solution here equals 9 over 2. Okay, here was an example from the 2000 exam way back in 2000. Okay, and this one was a graphing calculator question. You have to be careful with this one because they give you the two functions and they want you to find the area between these two curves. Now it appears on this graph that the intersection point is 1, but we're going to find out that actually it isn't 1. So sometimes the sketches, you can't take them for verbatim. You have to actually prove what the intersection point is. So here's what we're going to do. First of all, I'm just going to clear out this stuff. And this is a graphing calculator question. So the first thing I'm going to do is I'm going to graph the first function, which was e to the negative x squared. So on the graphing calculator, again, it's going to be e raised to the negative x squared. If I hit enter, I get a graph that looks like that. And my second function was 1 minus cos x. So 1, whoops, to get a second function, you have to hit the tab key. And then you type in 1 minus trig. It's going to give me cos x. And hit enter, and I get a graph something like that. And I'm going to change my windows, because if you notice here, this window is going from 0 to 1 and 0 to about 1.5 in the x direction. So I'm going to just go menu, window, window settings, and I'm going to change this guy to be 0, and my x max, even if I go to 2, and my y minimum to 0, and my y max to 1. And then I should get a picture a little closer to what I have on my handout. And there we go. So now we want to find the intersection point. So to do that, I'm going to go menu, analyze graph, and I want an intersection point. And now it's asking me for the lower bound, so I move my cursor to the left of the intersection point and hit enter. Then it asks for the upper bound, so I move it to the right and hit enter. And notice I get a decimal number of 0.941944441. And quite often we want to store this, so you have to highlight it. And then you have to go control bar, and I'm going to call that variable A. And I'm going to hit enter. And notice it comes up bold type, which means it's been stored. So on my test paper, though, I would be sure to let the AC people know what I'm doing. So in this case, I would go that A equals, whoops, 0.9419441. 0.9419441. 0.9441, just so they know what A is. So now to figure out the area of region R, it's the integral from 0 to A. My top curve is e to the negative x squared minus the bottom curve, which was 1 minus cos x dx. Now to solve this on the calculator, I am going to go back to my calculate screen, which is right there. Go back to my definite integral, and now I'm going from 0, and I've already stored my intersection point as variable a. And now to save yourself some time, when I graph these, I put the e to the negative x squared as function 1. So if I go var, I can bring in function 1 with respect to x, and then I'm going to subtract, whoops, I want that outside the bracket, sorry, so bring your cursor outside, minus var, function 2 was the 1 minus cos x, but you have to put in an x to tell it you're doing it with respect to x, and then a dx there. If I hit enter, 0.591, round off to 3 decimal places. So that would be the area between the two curves using technology. Okay, we'll take a look at some of these other ones. I'll let you try this one on your own as part of your assignment. So you just have to do part 4A, and you can do part 4B as well in this question. And now we want to briefly look at integration with respect to y. So sometimes the boundary of a region are more easily described by functions of y than by functions of x. So for example, in this question, we have the area trapped between the two curves, x equals 2y and x equals y squared minus 3. Now, if I tried to go top minus bottom, if you notice to the left of this line, the top curve and the bottom curve is the same parabola. However, if you were to turn your paper sideways, the top curve would be the black line and the bottom curve would be the parabola. So I'm going to integrate this from right to left. So now what I'm going to do is I'm going to find my intersection points. And notice that in this case, both equations are in the form x equals, so I can equate 2y to y squared minus 3, set it equal to 0. This is going to be y minus 3, y plus 1. So I get y being 3 or y being negative 1. So this intersection point is negative 1. And this intersection point up here is where y is 3. So now to find the area, I'm going from negative 1 to 3. So now I'm using the y coordinates of the intersection points. And the right curve is the line minus the left curve, which is the parabola, and I'm integrating this with respect to y. So if I simplify this, I get something like that. And now I am going to integrate. So this is going to be the definite integral. And this one is going from negative 1 to 3. And my function was 2y minus y squared plus 3. So 2, and again, I'm just going to use x. So I guess I can use y. It doesn't really matter. So 2y minus, I forgot what the equation was, y squared plus 3. And now you just have to tell the calculator you're integrating with respect to y. And if you hit enter, you get 32 over 3. So therefore, this answer is going to be 32 over 3. So in general, if f and y and g and y are continuous functions, with f of y being bigger than g of y, meaning it's to the right of g of y, then the area between the two curves is basically right curve minus y curve from the y coordinates of the intersection points. Okay, so we want to find the area bound by the graphs x equals 3 minus y squared and x equals y plus 1. Now, when you're entering these into your calculator, you have to enter them in the form y equals. So I'm going to add the y squared over and subtract the x. And now when I square root this, it's going to be plus or minus 3 minus x. And my second equation is going to be y equals x minus 1. So if I go to my graphing calculator, okay, I'm going to go back to my graph. Again, menu. I'm going to actions, menu, actions, delete all. It's going to ask me yes. I'm going to go back and change my windows to my standard window. And now I'm going to graph my first function. And my first function is going to be the positive branch of the square root of 3 minus x. So it's going to be the square root of 3 minus x. And that's going to be the first function. And then I have to do the negative branch of that. So negative square root of 3 minus x. And then the last equation was x minus 1. So it's going to be x minus, I have to go tab, x minus 1. Okay, so we're looking for this region right in here where the cursor is. Okay, and notice that if I turn my calculator sideways, I'm going to have the parabola on top and the line on the bottom. So I need to first of all find the intersection points between these two curves. I need the y intersection points here. And I could use technology as well. So I'm going to go menu, analyze graph. I want the intersection point. But notice there's 3 graphs on here, so the calculator doesn't know which 2 you want. So let's first of all pick this as my first graph, and this guy as my second graph. So move the cursor to the left, to the right, and you'll notice that the y intersection point is 1. And then I'm going to do the same thing for, now I'm going to choose the red graph and the black graph. I'm going to go to the left of the intersection point of those 2 and to the right. So the y coordinate is -2. So my limits are going to be -2 to 1. So therefore, I'm going to find the area. That's going to be the integral from -2 to 1. Those were the y coordinates of my points of intersection. And my right curve, if I graph or leave in the form x equals, my right curve is going to be the parabola 3 minus y squared minus the linear function, which is y plus 1 dy. So this is going to be -2 to 1, 3 minus y squared. I'm going to distribute that right away. So let's get rid of those brackets. So -2 to 1 of 3 minus y squared minus y minus 1, which is going to equal the integral from -2 to 1 of 3 minus 1 is 2 minus y squared minus y dy. So I'm going to enter this into my calculator. So I have to go back to the calculate screen. And I'll get rid of this stuff that's in there. And I'm going to go here. And I'm going to select this guy. And now I am going from -2, not -3, but -2 to 1. And now my integral or integrand is 2 minus y squared minus y. So 2 minus y squared minus y, and I'm integrating with respect to y, and I get 9/2 is my final answer. So there is how you integrate with respect to y. Now sometimes you're going to have to convert these equations into the form x equals, but in these examples that was done for you. Okay, so there is your assignment from your Calc 30 textbook, from the AP Calc book. These ones here, 3, 4, and 18, you have to integrate with respect to y. And from your handout, behind at the back of your handout, there's a question here. You could do part A of the 2007 one. You could do part A from the 2006 one. And you could do part A and part B. You need a calculator for these. And you could do part A from this one as well. And you could also do part A from this one. So there's lots of practice questions from the AP exam that you can do. Try these. Again, you could do A and B from 2001, and that's the last one. So your assignment is quite detailed here. You have plenty to do. So give those a try and see how you do.